Hi, this is Amar. This is my ICP 6. So here I have imported all the libraries required. So here I'm reading a text file uh, from the book The Alchemist. And here are the first 250 characters of the text. Here I am using sort of set of text to extract the unique words from the text. So we have 86 unique characters, and that includes punctuations also. Uh, Here I'm converting the text into vectors for easy processing. So here I'm first converting the characters to index. I'm giving index for each character in the text. I'm then converting the invert index to character using numpy array, and here I'm converting the text as the integer values. Here the first 5 characters of the text. Here I've converted the individual characters to some desired size. In this case it's 5. Here for each sequence, the duplicate and shift, I'm using map function to split the input target, and here it is, the input data and the target data. You can see the difference here. The input data is uh, one text ahead. Here I'm giving the batch size of 64 for the training purpose. Here is the data set. It's time to build the model. I have given the vocab size as the length of vocab and embedding dimensions to 56 and 102 for RNN units. And for building model, I have used GRU and added a dense layer of vocabulary size. And for building the model, I've just passed the parameters here for this function, and it's time to fit the model. Here, yeah, this is the batch size and the sequence length and unique vocabulary size. And here is the summary of my model. I'm using GRU. And here is just a sample. Uh, like I'm giving the text and it generates the random numbers for it. This is the sample for it. And it's time to train the model. It is the prediction shape and the scalar class. Before fitting it, we have to compile the model. I have used Atom Optimizer, and these are the checkpoints. And if I have used 10 epochs to train the model, and it generated a loss of 1.68 and accuracy of 50%, which is not that good. So let's predict uh, the text. For generating the text, I have used the function I have defined a function here, and here I passed Egypt, so it generated some text here. Um, Here it was not so accurate, and here you know there are misspelled words and punctuations overall. This is not so accurate, so it's time to tune the parameters. So I have changed that box from 10 to 25 here, and batch size 64 to 128. Learning rate from the default 0.01 to 0.1, and I've used LSTM layer instead of GRU. So I've used tanh and sigmoid functions, activation functions inside the LSTM. I given the dropout 20%. It's time to build the model, and here is the summary of the model. And here is the batch shape 128 by 100, 128 by 100. And I have used Adam as my optimizer. So it's time to fit the model. Here I got 1.24 loss percent, which is really good, and an accuracy of 62.08. So it's time to generate the text. I did pretty good in generating the text, so there are some words misspelled. Some punctuations are not in order. Yeah, overall it did a decent job. So to tune furthermore, I have increased the box and decreased the batch size to 64, and setting the learning rate as usual, it's to its default. I'm adding one more LSTM layer here with a dropout percentage of 20% after every layer. And here is how it performed with a loss of 0.3% and an accuracy of 93.06%. This is the predicted text. Here it did a decent job. Overall, you can see the punctuations are in line, and there are very less misspelled words here, and the text also makes sense. So yeah, it did pretty good with an accuracy of 93%. Thank you.